In this lesson, we will discuss measuring length, the systems in which this can be done, and how to do conversions between these units. There are two main systems, the metric system and the English system, and we'll start with the English system. Now, globally, the metric system is the system that's most commonly used, and I believe the English system is only used in the United States, I think Liberia, and Myanmar. And that's it. So for measuring lengths or distances, these are the units in the English system. There's inches, feet, yards, and miles, and these are the connections between them. 12 inches is the same as 1 foot, 3 feet make a yard, and 5,280 feet make 1 mile. So using these conversion factors, we can change one unit of measurement to another. And let's try that in example 1. I'd like to convert 2 feet into inches. So looking up here, I want to use the conversion factor that has both feet and inches in it, and that's this one. And this says for each 1 foot, you have 12 inches. Well, if you want 2 feet here, you can double both sides to say that 2 feet is equal to 24 inches. Let me write that over here. So what we're doing is we're taking this conversion factor, we're saying 12 inches is equal to 1 foot. Those two things are equal, and we can do the same thing to both sides of this equation. We can double both sides. And if you double 12, you get 24. And if you double 1, you get 2. And that tells us our answer. I mean, really, this is a lot of work to get to this answer. I bet you probably knew the answer ahead of time. Really, the amount of work you need to show for it would look like this. You take 2 feet, you multiply it by 12, and the number you get is 24, and the units have to be inches. On the next slide, we will take a more in-depth look as to why this works. But before that, let's try something similar here in example 2. We have that a football field, and so in the United States, is comprised of 2 end zones, each of which is 10 yards in length, and 100 yards separates the 2 end zones. So what is the length of the football field, not in yards, but in feet? I'll draw a rectangle that represents the football field. So we have something that looks like this. One end zone on the left and one on the right. So we're told for this end zone, the length of it is 10 yards. So that's from here to here. That length is 10, and then YD is the abbreviation for yards. From here to here, this is 10 yards as well. And then separating them from here to here is 100 yards. So in feet, how long is this distance? This really could be done 2 ways. You could add these numbers up to get one distance in yards and then multiply that by the appropriate conversion factor, or you could find each of the 3 pieces separately in feet and add those together. They're all very similar. I think I'll take the first approach. I'm going to add up this length in yards. So 10 plus 100 plus 10. So the length of the football field is 10 yards plus 100 yards plus another 10 yards. All the units are the same, so these numbers can be added together to 120 yards. This is the length in yards of the football field. How do I convert this into feet? Well, I'll look at my conversion factors and choose the one that connects yards and feet, and that is this one right here. For every 3 feet, there is 1 yard. But I want this to be 120. So what could I do to both sides of this conversion factor for that to happen? I can multiply both sides by 120. I can multiply 3 by 120 and 1 by 120. I'll actually put that work down here. We are told that 3 feet is the same thing as 1 yard. If we multiply both sides of this by 120, we get the unit correct on the right. We get that this is 120 yards, but on the left, we get 120 times 3. That is 360. And the units are feet. Again, this is a lot of work. What really can you do to this number to get to the final answer of 360 feet? Well, you can take 120 and multiply it by 3. Like, really, you only need to do this. 120 yards times 3 will give us our answer of 360, but now the units are correct. They are in feet. So 360 is the answer for example 2, and 24 inches was the answer for example 1. So like I said, on the next slide, we'll take a closer look as to why this simple process of conversion can work. The technical term for what we were doing on the previous slide is called dimensional analysis, the term used to describe converting from one unit to another. So more precisely, dimensional analysis is the process of changing from one unit to another by multiplying by a unit fraction. And a unit fraction is one with different units between the numerator and the denominator, but the value of the fraction is equal to 1. This says quite a bit, but let me try to describe this. First of all, what is a unit fraction? A unit fraction has to be equivalent to 1. So with no units, that would be something like this. 5 divided by 5. Is this a unit fraction? And the answer is yes. The top and bottom are equal, and when you simplify it, you get 1 back. So you could say like, oh, okay, well, this is a unit fraction. I mean, over here, it doesn't look like 1, but it is equivalent to 1 when you simplify it. Now, what happens if you start including units into the fraction? Can you still make unit fractions from these things? I'm going to write down a fraction. Let me see. How about 12 divided by 1? Is this a unit fraction? And the answer is no. And the reason is, if you just say 12 over 1, well, that's equal to 12. It's not equal to 1. However, if you put 12 inches on the top and you put 1 foot in the denominator, is this a unit fraction? And the answer is yeah. Even though the numbers are different, 12 inches is completely equal to 1 foot. So when you simplify this thing, even though the numbers are not the same, it is still equal to 1. And that's because 12 inches with the units is exactly the same thing as 1 foot. Another unit fraction would be, well, what if you had 1 divided by 12? That's not a unit fraction. But if you put 1 foot divided by 12 inches, well, this is a unit fraction. The numerator and denominator are exactly the same. So they cancel just like this up here to give you the value of 1. You can do that for all these conversion factors. For example, 3 feet to 1 yard. Here is another unit fraction. 3 over 1 is not, but 3 feet over 1 yard is a unit fraction. Likewise, 1 yard over 3 feet is a unit fraction too. It's important to include the units here. The last two using the conversion factors are, if you said 5,280 divided by 1, as long as you put feet in the top and miles in the bottom, well, then you're okay. And the other one would be if you flip the fraction. 1 mile is equal to 5,280 feet. Therefore, if you divide them, the value is still 1. So how do these things help you when doing a conversion like 2 feet into inches? Again, this was very simple, but I'm choosing this to describe how this process works. So here's how it goes. You have 2 feet, and you want to convert it into inches. The trick is, what we're going to do is we're going to multiply 2 feet by 1. If you take 2 feet, or anything for that matter, and you multiply it by 1, you've not changed the value of the thing you started with. This is the same thing as saying 2 feet. But you can replace 1 with any one of these fractions. I'm going to choose the one that will cancel the feet and leave the inches remaining so we get our answer. And that will come from this fraction here. So instead of writing 1, I'm going to replace that whole thing with this fraction. So this whole thing is equal to 2 feet times the fraction 12 inches over 1 foot. So this looks very different, but this is still equal to 2 feet, and that's because this fraction is really saying multiply by 1. When you're multiplying two fractions together, sometimes it's nice to write everything as a fraction. So we're really saying 2 feet divided by 1 times 12 inches divided by 1 foot. How does this help? You can cancel anything between a numerator and a denominator when you're multiplying fractions together. And this goes for units as well. If you're looking to cancel feet, you would divide by feet. So you can actually cancel out the unit. Feet and feet cancel. They're gone. Nothing else cancels here, and notice that the denominator is just 1 times 1 with no unit. So I'll write that next. If we now multiply the fractions across, the denominator is 1. What's left on the top? 2 times 12 times inches. So that's 2 times 12, and then multiplied by the only unit remaining, which is inches. And in fact, we're just saying 2 times 12 inches, which is 24 inches, and that's our final answer. This is why multiplying by 12 worked on the previous slide. When we said multiply by 12, technically we were multiplying by 12 inches divided by 1 foot. And since feet was in the denominator, it canceled the feet that was in the numerator in the start of our problem. And then inches was the unit that was left over. Here we again have the units of conversion for the English system. And in example 4, I want to perform the following conversions, but using dimensional analysis, just to make the process more clear. Let's start with 90 yards to feet. So the process would be, you write down 90 yards, this is your starting point, and you want to multiply by 1. This time I won't actually write the number 1, you can if you would like. Instead, I'm going to jump to the part where we have a fraction that's equal to 1. So what I want to do is I'm going to set up a fraction. We're going to multiply by a unit fraction. Now, I want to cancel yards. Therefore, yards has to be in the denominator. So I'm going to put yards in the denominator. And the unit that we want left over is feet, which I'll put in the numerator. This is how I start the process when doing a conversion that I'm having trouble with. I set up a fraction, I put the units I'm trying to cancel in the denominator, and the units I want left over in the numerator. Now, to make this thing a unit fraction, I want to put numbers here so the top and the bottom are equal, and I can look up here to my conversion factors. Well, for every 1 yard, there are 3 feet. So I'll put a 1 here and a 3 here. So that's a 1 yard is 3 feet. I'll write the first thing as a fraction. When I multiply these two fractions together, we can now cancel yards. They cancel because one's in the numerator and the other is in the denominator. Here is everything that's left over. We have just 90 divided by 1 multiplied to 3 feet divided by 1. There are no more yards, and the unit that we want is left over, which is feet. So if I multiply the bottoms, we get 1. I say at this point, if the denominator is completely 1, we don't need to write it. Dividing by 1 doesn't change anything. All we need to do is multiply the top, which is 90 times 3 times feet. 3 times 90 is 270, and I have my units of feet, and that is my answer. So 90 yards is equivalent to 270 feet. I'm going to put an extra one in here that wasn't in this problem. What if you wanted to convert 90 feet into yards? What would that look like? So not from yards to feet, but 90 feet into yards. The process would be, you want to multiply this thing by a unit fraction. You want to cancel the units you don't want by putting them into the denominator, and then including the units that you do want in the numerator. This means you have to have feet in the denominator this time, and yards left over in the top. To make this thing a unit fraction, what number goes up here and what number goes down here? Well, for every 3 feet, there is 1 yard, so I'll put there's 1 yard for every 3 feet. To multiply these fractions together, I can cancel feet, so feet cancels with feet. Yards is the only thing that's left over. Let's multiply this all together. This is equal to, we have 90 times 1 times yards. I'll just put 90 yards. And in the denominator, well, it's not all 1 this time. There are no units, but it's 1 times 3, which I do have to include, and that is 3. This is 90 times yards over 3. This is the same thing as 90 divided by 3 yards, since yards is in the numerator. Well, 3 goes into 90 30 times. So that is 30 yards. So 90 feet is equivalent to 30 yards. Okay, now what about the next one, which is 53 1/3 yards converted into feet? Okay, so we have to multiply this thing by, well, I want to cancel yards and end with feet. And I know, well, there's 3 feet for every 1 yard. This one's a little confusing because over here we have a mixed number that is a whole number and a fraction being added onto it. What I'd like to do in this case is write this thing as an improper fraction. So a review here, a mixed number is some whole number. So in this case, it was 53 1/3. And if you want to change that into an improper fraction, the process is to take 3 and multiply it to 53 and then add 1 to it. The denominator would remain 3. So it looks like this. Your denominator is 3. You do 3 times 53. And then you add on 1. And we want to leave this as a fraction whose denominator is 3. Okay, 3 times 53, 159. And 159 plus 1 is 160. An improper fraction means that the numerator is bigger than the denominator, and it's another way to write something that is a mixed number. I'm going to replace this fraction with this improper fraction. So this is really 160 over 3, and we still have the units of yards left over. And this is being multiplied to 3 feet for every 1 yard. Now, written this way, we can cancel the units. Those cancel. But we actually have a number that we can cancel too. I can cancel this 3 with this 3. One's in the top and one's in the bottom. The rest is multiplying across. Okay, so in the top we have 160, and that's it. And the units of feet. And in the denominator, after we cancel these, only 1 is left over. The entire denominator is 1, and therefore this is our answer, 160 feet. By the way, we had that the length of a football field was 360 feet. This is the width of a football field. It is 160 feet, or 53 1/3 yards. Okay, last one here. I want to convert 1.261 billion feet into miles. Okay, let's see. Okay, 1.261, and that's billion feet. That's quite a bit. And we want this to become miles. Okay. First of all, I don't like including this billion here. I might want to move this decimal point so it's equivalent to billions, so we don't actually have to state this unit. So for billion, that was a 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So we want to take this decimal point, and if we multiply it by billions, it's going to move to the right 9 times. Okay, so that is equal to 1,261. So there's 3 times it's moved. 1, 2, 3, another 3 times. 1, 2, 3. So this is 1.261 billion. So the billions I don't have to state as a unit, and I can just put feet like this. Okay, so this many billion is the same thing as this number here. And now the process becomes the same. I want to cancel feet, but this time I want to end in miles. So for my unit fraction, I want to cancel feet, and I want to be left over with miles. And the unit, or the conversion factor I want to use is this one here. For every 1 mile, there's 5,280 feet. So I'll put a 1 here and 5,280 here. Again, I'm multiplying these fractions together. We can cancel the unit of feet, and essentially, we're going to take this number and divide it by 5,280, and only miles will be left over. I'll put that over here. And I'm actually going to do this in my calculator. So 1,261,000,000 divided by 5,280. Okay, this is 238,825. And I guess I'll round to maybe the nearest tenth. So that is 5.8, and this is now in miles. So this is the answer for how many miles we have when converting from feet. And by the way, this is the average distance from the Earth to the moon. The other measurement system we will consider in this lesson is the metric system, and this is based on the meter. 1 meter is a little bit more than a yard, so they're approximately equal to each other. The nice thing about this system is the units are all based on a meter. Notice for all of these things over here, they all relate back to meters. And not only that, they relate back to it by factors of 10. That's the reason this system is often preferred to the English system. Converting within the system is a little bit easier. The reason is every time that you go from one unit to another one, you're only multiplying by a factor of 10. So if you take meters and multiply by 10, that's a decameter. If you multiply by 10 again, or multiply by 100, that is a hectometer. If you multiply by 10 3 times, or 1,000 meters is a kilometer. To go in the other direction, to get smaller units of measurement, you divide by 10. So a decimeter, you divide by 10 once. A centimeter, you divide by 10 twice, or 100. And then a millimeter, you divide by 10 3 times, or you divide by 1,000. So these are for measuring long distances, and these are for measuring very small distances. Let's try this out in example 5. We're going to perform the following conversions, and I'll start with this one here. I'll first use dimensional analysis, so let's try it out. So we have 5 kilometers, and we want to end up with meters. Using dimensional analysis, you want to multiply by a unit fraction. The denominator should be kilometers because we want kilometers to cancel, and the numerator should be meters because that's what we want left over. I look up here and I see that, oh, okay, well, for every 1 kilometer, there's 1,000 meters. Therefore, I'll put 1,000 on the top, 1 on the bottom. Just like last time, I think I'll make this a fraction because when multiplying 2 fractions together, we can cancel units between the numerator and the denominator. And all we have to do now is note the denominator is equal to 1. I don't have to write it. This is just 5 times 1,000 times meters. This is a very easy multiplication problem. In fact, it's 5,000. So 5 times 1,000 is 5,000. And we have meters as our unit left over. And that's it. There is a much faster way to do this than dimensional analysis. All you need to do is look at the decimal point after the 5 and move it 3 places to the right. This is how I would actually approach the problem. So I would say, all right, we're starting with 5 kilometers and I want to end up with meters. So we're starting up here and I want to go in this direction down here. First of all, is the number getting smaller or bigger? The number is definitely getting bigger. Notice that if 1 kilometer is 1,000 meters, if you have 5 of these things, this thing should be 5 times as large over here. It's a little counterintuitive, but if you move in this direction, the number must get bigger. This tells me the decimal point is moving to the right and not the left. So moving in this direction, the number gets bigger. The second thing is, well, how much bigger? How many times am I moving the decimal point? If we start here and we want to end here, that's a total of 1, 2, 3 times. So I'll write this as 5.000 kilometers. And I'll note that if we're starting here, we have to go 1, 2, 3 times to get to meters. So that's moving this 1, 2, 3 times. And then once you've done this, once you've actually moved the decimal point, our answer is 5,000, and that is now in meters. And this is the answer. This is the nice thing about metric. The multiplication is very simple. In fact, really, you should only move a decimal point, either to the right or to the left. Let's try this again with 5 kilometers to not meters, but decimeters. What about this one? For this problem, we're starting with 5 kilometers again, and we're looking to go not to meters, but one further here. Well, the number has to get bigger because we're going to a smaller unit of measurement. That means we're going to balance it. And we're not moving 3 times, but we're moving 4 times. We're multiplying by 10 a total of 4 times. So I'll write this again as 5.0000, just add enough zeros so I can do the math. We're now moving it a total of 1, 2, 3, 4 times. And the number that we get for our answer in meters is 50,000. 50,000. That's 50,000 decimeters. So 5 kilometers is 50,000 decimeters. What about 17 millimeters to centimeters? So we're starting at millimeters and we're going to centimeters. Since we're going up in the unit of measurement, the number should get smaller. So I'm going to start with 17 millimeters, and the decimal point is here. Moving in this direction, the number should get smaller, and it should get smaller by a factor of 10. So the decimal point is here. We're not going to move it to the right, then I'll make the number bigger. In fact, we want to move it to the left. We're going to move it one place. So we're starting here and we're going here. We started with millimeters and we went to centimeters. Therefore, the answer is 1.7 centimeters. 1.7 centimeters is the same thing as 17 millimeters. So here is our answer. And one more, 35,000 millimeters to hectometers. So we're starting with millimeters and we're going up here. So the number should get smaller. And the number of times we move the decimal point is 1, 2, 3, 4, 5 times. So we're starting here and going 1, 2, 3, 4, 5. And if I write that down for this problem, so we have 35,000 millimeters, and the decimal point is here, and we want to move it a total of 1, 2, 3, 4, 5 places here. Therefore, our answer is going to be equal to 0.35 hectometers. And that is the answer for this last part. Since there are two different systems of measurement, there should be some way to convert between the two systems. And that's what these conversion factors can be used for here. So 1 inch is equal to 2.54 centimeters. Technically, those aren't exactly equal, but they're very close. You might sometimes see 1 inch is approximately, so the wavy equal sign to mean roughly 2.54 centimeters. They're very close, so in some cases saying equals will be good enough for what we're doing. Likewise, we have 1 foot is equal to 30.48 centimeters. You might also see 1 foot is approximately equal to 30.48 centimeters. They're very close. We also have that 1 yard is equal to 0.9 meters. You could see 1 yard is roughly 0.9 meters. And 1 mile is equal to 1.6 kilometers. Well, they're approximately equal, 1.6 kilometers. Let's try applying these conversion factors in example 6. I'd like to use dimensional analysis to perform the following conversions. And let's start with this one here, 28 inches into centimeters. So if we start with 28 inches, the process is going to be the same. We want to multiply by a unit fraction. I know I want inches in the denominator, so it cancels. And we want centimeters left over in the numerator, so that unit remains. I look to my conversion factors and I see, here's one that contains inches and centimeters. I'll put 1 inch in the denominator and 2.54 centimeters in the top. This is a unit fraction, 1 and 2.54. We are again multiplying two fractions together. We can cancel anything between the numerator and the denominator, so inches cancels. The denominators are all equal to 1, so we don't even need to write it. We can just do 28 times 2.54, and centimeters we left over as our unit. I'll do that in my calculator, and I get 71.12 and centimeters. So in some sense, you could say that these are equal. Technically, this is approximately equal, and in most cases will be good enough. So that is the answer for this first part. Now, what about converting 17 decimeters into inches? You look over to your conversion factors and you hope to see decimeters and inches, and unfortunately, I don't see decimeters anywhere. I do see centimeters and inches, so we can use this conversion factor, but I think there's going to be a preliminary step. I first want to convert 17 decimeters into centimeters, then I can use this conversion factor to convert that into inches. So because I don't see this unit anywhere over here, we have a preliminary step. So we're going to start with 17 decimeters, and we want this to go to centimeters. On the previous slide, we had, I think it was meters, decimeters, and then centimeters. So if we're going from decimeters to centimeters, that's going down once. If you go to a smaller unit, the number should get bigger, and we're moving the decimal point once. The decimal point on decimeters is here. It's going to be a bigger number, and in fact, that number is 170. So here, we just took this decimal point and moved it over one place to get to centimeters. Now, because we have centimeters, I can use this conversion factor to get to inches. So I'll take this number and multiply it by something with centimeters in the denominator and inches in the numerator. For every 1 inch, there is 2.54 centimeters. So what do we do here? We cancel the centimeters. 1 is not left over in the denominator. 2.54 is. I'm going to do 170 times 1 divided by 2.54, and inches is the unit left over. I'll write that as 170 divided by 2.54, and this is inches. In my calculator, I think I'll round to 1 decimal place. The number I see is 66.9, and the unit is in inches. And for the last one here, 98 kilometers into miles. How do we do that conversion? Well, for this one, there is something connecting kilometers and miles, so I can simply just use this conversion factor. So for this one, I have 98 kilometers. I want to multiply by a unit fraction with kilometers in the denominator and miles in the numerator. For every 1 mile, there's 1.6 kilometers. Therefore, when we multiply these fractions together, we cancel the kilometers. What's left over is 98 times 1 times miles. In the denominator, we have 1 times 1.6, which is 1.6. This is equal to 98 divided by 1.6, and the only unit left over is miles. This time when I divide, I get 98 divided by 1.6 is 61.25, and that is in miles. And that is the answer for this last part. In our last example, let's use dimensional analysis to perform the following conversion. 98 kilometers per hour to miles per hour. This is a little different than what we've done up to this point. The difference we have here is when you say 98 kilometers per hour, we're talking about a speed, like something you could drive in a car. And really what this means is you are going 98 kilometers for every 1 hour, and we just abbreviate it as kilometers per hour. This speed could be converted into miles per hour. So you could write this as some number of miles for every 1 hour, or simply some number of miles per hour. How can you do this using dimensional analysis? Let's see if our process will work in this type of question. This time we're starting with 98, and that is kilometers for every 1 hour. Our goal is to cancel the kilometers and replace it with miles. And here we have hours, but I don't want to do anything with hours. I'd like that to remain within the fraction. If we use the process of dimensional analysis, you want to multiply by a fraction that will cancel kilometers but leave miles. Well, that means kilometers is in the denominator and miles is in the numerator. In fact, on the previous slide, we had a conversion factor that said 1 mile is equal to 1.6 kilometers. Using this fact, I'll put a 1 here for miles and 1.6 for kilometers. In doing so and multiplying these fractions together, the kilometers cancel. What do we have left over? 98 times 1 times miles. Let's put this in a fraction. That's 98 times 1, which I'll just leave as 98, and our unit is miles. This is divided by 1 times hours times 1.6. 1 times 1.6 is 1.6, and the unit attached to that is hours. This has to tag along too. The next step is we can divide 98 and 1.6. I'm going to do that on a calculator. So 98 divided by 1.6 is 61.25. And the units are still left over. When I divide this into this, we have miles, and there's 1 hour in the denominator. So this is miles, and we still have hours, or 1 hour if you'd like. The way we can express this simply is to say 61.25, and the units are miles per hour. So we can use the same process even when converting not just a single unit, but some type of speed or velocity.